Hello everyone. Today we will discuss about the force on a moving charge placed in a magnetic field. As this topic is based upon the idea that when a current carrying conductor is placed in a magnetic field, then it will experience a force that we already described the formula to. We got F equals to I, L, and B. This is the formula that we got. From this formula we will derive another formula that will give a relation between the force on a moving charge when it is placed inside a magnetic field. Here you can see that these are the charges that are moving through the conductor, which we can say that the current is passing through the conductor and the conductor is placed inside the magnetic field. So this conductor as a whole will experience the force according to this formula. And if I replace I by Q upon T, then the formula will become 𝗙𝗹𝗵 upon T. And as we know, L upon T is equal to V. So we can put in Q, V, and V. So Q stands for charge, and here the charges are electrons. By replacing Q is equals to electron, I can write the formula E, V, and B. This relation is in the magnitude form. We can write it in the vector form. F equals to E as its magnitude of electron and V. Cross BV is the velocity of electron, and V I can say magnetic field of electron by removing this cross and writing it again in magnitude form. This will be in terms of EVB and sine theta. So from this form, I can say that if theta equals to 90 degrees, there will be a maximum force F equals to EVB because sine 90 is equal to 1. And in the case of theta is equal to 0 or 180 degree, theta is actually the angle between velocity and magnetic field velocity. Here the velocity and magnetic field velocity are both perpendicular to each other. If they're parallel or anti-parallel to each other, then there will be no force experienced by the charge. We can also say that for neutral charges, they will go undeflected through the field. There will be no force that will be applied to them, as the charge on that particle is also zero. One more situation in which the force applied on the particle is zero is when the velocity of the particle is zero. So the charge will be at rest. So we can conclude that there is multiple situations in which the charge acting on a particle is zero. Like if magnetic field and force are both parallel or anti-parallel to each other, or if the charged particle is neutral, meaning that there is no charge on the particle, or if the charged particle is stationary, which means there will be no motion present in the particle. So this is the only case in which the force acting on the particle is maximum. Theta is 90 degrees, as the velocity of the electron and the direction of the magnetic field are perpendicular to each other.